Hi, I am Gopalakrishna Ranjan. This is our third example in the series Unfolding Set-Based Approach. In this example, we are going to learn how and when to use apply operator in SQL Server and how to compare rows on a given logic. Let's understand the table, data and the required output now. This is the employee master table which has two columns, EMP ID and EMP name, where EMP ID is a unique number which is used to uniquely identify each employee, and EMP name is the full name of the employee. And this is the project master table which has two columns, project ID and project name, where project ID column stores the unique ID of the projects and project name column stores the name of the projects. Now assume that the employees of SQL release company keeps moving from one project to another project along with time, and this data is being stored in a table named as employee project detail, which is as this. Here row ID column is an identity column which stores the unique row ID for each row. EMP ID column stores the unique ID of the employee. Project ID column stores the unique ID of the project, and effective from date column stores the date from which employee gets allocated on the project, and effective to date column stores the end date of employee on that project. Now have a look on the table data. Let's talk about the employee ID 1 first. Here we can see that the employee with employee ID 1 is assigned to the project ID 1 for the period of 1st Jan 2012 to 30th June 2012. Then he moves to project 2 for the period of 1st July 2012 to 30th September 2012. Then he moves to project 3 for the period of 1st October 2012 to 31st October 2012. Again, from 1st November 2012 to 31st December 2012, he moves back to project 1. Then, from 1st Jan 2013 to 8th May 2013, he moves to project 4. Finally, he moves to project 1 on 9th May 2013 and remains assigned there till to 31st December 2016. However, even though the project of employee is not being changed thereafter, a record for the same project gets inserted in the table at the beginning of each year, like from 1st Jan 2014 to 31st December 2014, from 1st Jan 2015 to 31st December 2015, and from 1st Jan 2016 to 31st December 2016. Similarly, employee ID 2 is assigned to project 2 from 12 October 2015 and has no change throughout. However, we have two rows for employee ID 2 because employee gets reassigned to its current project at the beginning of year 2016. Let's talk about the employee ID 3 now. Firstly, employee ID 3 is assigned to project 1 for the period of 10th May 2014 to 10th September 2014. Then he moves to project 3 for the period of 11th September 2014 to 18th October 2014. Then he moves back to project 1 on 19th October 2014. Thereafter, at the beginning of each year, the employee gets reassigned to the same project, which results in a new record in the table, like from 1st Jan 2015 to 31st December 2015 and from 1st January 2016 to 31st December 2016. Finally, employee ID 4 gets assigned to project 4 and on 1st Jan 2016 and remains there till 31st December 2016. Next, we will talk about the required output. This is the employee master table and this is the project master table. The employee project detail table is this. Now we need an output as this. In this output, we can see that all the employees have been listed with their current project name along with the project start date. Also, please keep in mind that the start date which we have displayed here is effective from date of the current project, since employee is working continuously in the same project without any change. Let's understand this with the help of an example. So if we talk about the employee ID 1, employee name Adam, we can see that he is initially assigned on project 1. Then he moves to project 2. Then he moves to project 3. And then he moves back to project 1. Again he moves to project 4. Then he moves back to project 1 on 9th May 2013. And after that he is continuously working on project 1. The rows which are added thereafter for the project 1 with different time periods are a result of the reassignment entries being recorded at the beginning of each year even there is no change in the project of the employee. So for employee ID 1, the project name will be ERP and the project start date will be 9th May 2013 in the output. Similarly, we need to find out the project start date of each employee for the current project since employee is working continuously in that project without any change. Now that we have understood the requirement, let's discuss the challenges which we have in order to achieve this output in set-based approach. This is the employee project detail table and this is the required output. Now, if we write a subquery to extract the effective from date as this, which uses an order by clause in descending order on effective date column to extract the top one effective date for the employee ID 1, we will get project start date as this. However, this project start date is incorrect. This start date is a result of the project reassignment entry recorded at the beginning of year 2016 and the actual allocation date is this. So in this case, instead of extracting the last active row from the table, we would be needing to track back to the actual allocation row instead of extracting the reassignment row. Let's discuss the trick which can be used to extract the actual project start date for each employee. This is the employee project detail table and this is the required output. Let's consider employee ID 1 as an example to understand this. In order to extract the actual project start date for the employee ID 1, firstly we will extract the project ID and start date on which employee is currently assigned. Secondly, we will extract the end date of the project on which employee had worked just before the current project. Finally, we will extract the row which starts just after the end date of the previous project, and this way we will be able to extract the actual effective from date on which employee gets assigned to the current project. To accomplish all these steps in t-sql, we would be needing to write multiple subqueries, and we know that the subquery can extract only one column at a time. Also, we need to rewrite the subquery each time in case we need to refer the column being extracted in the subquery. That is why we are using cross apply and outer apply here. Cross apply and outer apply operators were primarily introduced to invoke table valued functions. Apply operator executes for each row of left input and finds the matches in right input and then returns the result set as per depending on their type. If you want to read more about the outer apply and cross apply with their use case scenarios, you can visit my blog post link shared in the description of this video or click on the annotation floating over the video. Let's discuss that how we can write a t-SQL query to get the required output from employee project detail table. So if we write a query with an outer apply as this to extract the current row for each employee, we get this output. Here we are using an order by clause in descending order on effective from date column to extract the top one project ID and effective from date for each employee. This query extracts the current active row for each employee as this. Now that we have already extracted the current project detail for each employee, here we are going to extract the previous project detail for each employee using another outer apply as this. To get the previous project detail, we are using an outer apply which uses an order by clause in descending order on effective from date column to extract the top one row where effective from date is less than the effective from date of the current active project and project ID is not equal to the current project ID. In this way, we get the previous project ID and their effective to date, which are as this. Also, if there is no previous project, we get null values in that case. As of now, we have extracted the current project detail and previous project detail for each employee. Now we can write another outer apply as this to extract the next row for the current project, which starts just after the previous project's end date. In this outer apply, we are extracting the top one record where project ID is same as the current project ID and effective from date is greater than or equal to the previous project's effective to date value. To get the first row, which starts just after the previous project's end date, we have ordered the result set by effective from date column in ascending order, not in descending. Here we get this output. Now we can see that we have extracted the actual allocation date for each employee successfully. Let's add project name instead of project ID in the output and finalize the query in next slide. This is our query so far. Now to add the project name in the output, we can use an inner join on project master table as this. Also, we have removed the star from the main select class and used the column names explicitly there. This will give the required output, which is as this. Let's have a demo in SQL Server now. Let's start using the set-based approach database. Now create the required objects here. Here we are creating employee master and project master tables and also inserting the records together. These are the sample records which we have seen already in the example. Now to get the current project latest start date, let's execute the final query which we have created in our demo, and here we get the output. If you want to have hands-on experience with the examples that we have covered here, you can download the scripts from our website's URL given in the description of, or click on the annotation being displayed over here. Please share your valuable inputs. Based on your inputs, I will prepare the next video. Thank you for watching.